At 0343 hours local time, the Obukhov State Plant in Saint Petersburg ceased to be a safe place. A fuel-air explosion tore through the main assembly hall, the building where Russia manufactured the radar tracking arrays for its S-400 Triumf batteries. The fireball climbed 140 feet above the roofline in under 3 seconds. Secondary detonations followed. Compressed nitrogen tanks, stored chemical solvents, the precision cooling systems that kept the radar components from warping. The building held for 11 seconds after the first detonation. Then, the northeast wall came down. But rewind 4 minutes and 12 seconds. The first drone to reach the complex struck a secondary utility annex 40 meters from the main hall. The explosion was clean, contained, no secondary, no chain reaction. The building absorbed it. On the thermal feed overhead, the operators watched the structure remain standing, the roof intact, the assembly lines inside untouched. The decoys had done their job, but so had Russia's defenses. 4 of the 12 strike drones that crossed into Leningrad Oblast that night had already been shot down. 3 more had their GPS signals overridden and were drifting northwest over the Gulf of Finland. That left 5. 1 had just wasted its warhead on an empty annex. 4 remained over the target. The window was closing. 12 drones had launched. 5 had made it through. 1 had already missed. This is how the remaining 4 found the right building, and what that building meant for Russia's ability to defend itself. To understand the full weight of what happened here, you have to go back 36 hours. Ukrainian military intelligence had been tracking the Obukhov State Plant, officially the Obukhovsky Zavod, located in the Nevsky district of Saint Petersburg for several months. The plant is not a generic munitions factory. It is the specific facility responsible for producing and assembling the search radar arrays and fire control tracking modules used in both the S-400 Triumf and the Tor-M2 air defense systems. Lose this building, and Russia cannot produce new Triumf batteries. It cannot replace the radar heads it has already lost in Ukraine. It cannot repair the tracking systems knocked out by Ukrainian ATACMS strikes on forward-deployed launch vehicles. This was not a logistics target. This was the source. But what the Russians did not know was that Ukrainian intelligence had already mapped the interior of the plant not from overhead imagery alone, but from the heat signatures of active manufacturing lines, cross-referenced with commercial shipment data, satellite radio frequency intercepts that identified the specific frequency of the radar calibration equipment running inside Building 7, the main assembly hall. They knew the night shift worked until 0400. They knew Building 7 ran hot its cooling systems, cycling at irregular intervals that a pre-positioned recon UAV had logged for 6 consecutive nights. The operation was authorized at 21:30 hours the previous evening. The force package launched from a position inside Ukrainian territory at 2218 hours. By midnight, they had crossed into Russian airspace, hugging the Estonian border, routing through airspace that Russian air defenses could not legally touch. By 0300, they were threading south through the Leningrad countryside. By 0331, they were inside the defensive perimeter of St. Petersburg itself. The force package consisted of 12 aircraft. The recon element was a single Autel Evo II dual 640T, modified for extended range and silent thermal observation. Twin sensor payload 640 by 512 resolution thermal alongside a 48 megapixel optical camera, with frequency hopping transmission and multi-constellation navigation that could pull position from GPS, Galileo, GLONASS, and Beidou simultaneously, making signal spoofing exponentially more difficult. It had been overhead the plant for 40 minutes before the first strike drone crossed the perimeter. It had already preloaded the precise thermal signature of Building 7's active cooling exhaust vents into the navigation system of every aircraft behind it. The strike element was 10 aircraft, a mix of platforms selected for their specific roles in the layered approach. 6 were FP2 quadrotor FPV drones modified with shaped charge heat warheads. 3. 2 kilograms of penetrating explosive capable of punching through 14 millimeters of armored steel before the shaped jet ignited what was behind it. These were the dagger fast, expendable, and accurate inside 100 meters. Their job was to reach Building 7. The remaining 4 were AN-196 Lyutyi fixed-wing strike drones, a platform with a 270-kilometer operational range, a 50-kilogram payload capacity, and a cruise speed of 130 kilometers per hour that made it nearly impossible to track on short-range gun radar. Their warheads were thermobaric, designed not to penetrate a single point but to collapse enclosed spaces through overpressure, filling the interior of a structure with a fuel-air mixture before igniting it. Against a building full of precision electronic components, volatile solvents, and compressed gas systems, a thermobaric warhead does not simply destroy a room. It destroys every room. 2 additional FP2 drones were designated as decoys. They carried no warhead, only a modified aluminum shell that mimicked the radar cross-section of a much larger aircraft. Their job was to climb, to be seen, and to pull missiles. The first wall of Russian air defense the swarm had to defeat was not a missile battery. It was a radar. The 55G6-1 Nebo-SVU is Russia's most capable 3D VHF early warning radar, a vehicle-mounted phased array that operates in the very high-frequency band, specifically because VH radar is effective against small, low observable targets that higher frequency systems miss. It can detect a target the size of a basketball at 60 kilometers. It feeds tracks in real time to the command layer above it. If the Nebo-SVU locks onto the swarm outside the city, the entire defensive network has time to orient, sort, and engage. The swarm's answer to the Nebo-SVU was altitude. The FP2 quadrotors crossed into the Saint Petersburg defense zone at 14 meters above ground level, low enough that the radar horizon of the Nebo-SVU, mounted on a vehicle roughly 4 meters above flat ground, simply could not see them. The curvature of the Earth and the urban clutter of the Leningrad countryside created a blind shelf below 40 meters. The swarm flew inside it. 2 of the AN-196 Lyutyi fixed-wing drones, the heaviest and most valuable aircraft in the package, climbed deliberately to 200 meters as they crossed into range. Not because they were reckless, because they were the bait. The Nebo-SVU locked them immediately. 2 contacts, closing on the city, behaving like conventional cruise missiles. The track went to the command net. The network lit up, and while every radar dish in St. Petersburg's outer ring rotated toward 2 aircraft at altitude, 10 more crossed the radar horizon at 14 meters and continued south. Inside the S-400 battery positioned on the southern approach corridor, the fire-controlled radar, the 91N6E Big Bird, had 2 tracks. Both the AN-196 decoys were illuminated, cross-referenced, confirmed. The battery commander had a legitimate decision to make: launch against 2 confirmed aerial targets or wait for the swarm that his radar could not yet see. He launched. 2 48I-6 missiles, 1,900 kilograms each, Mach 6.5. An engagement envelope of 250 kilometers left the launch vehicles. Cost per missile: approximately $2 million. The first decoy climbed to pull the incoming missile away from the second. The second climbed east. Both missiles guided true. The 2 AN-196 Lyutyi decoys were destroyed over the Gulf of Finland at a combined cost of roughly $140,000. The missiles that killed them cost 28 times that, $4 million. 2 drones. The S-400 battery had just fired both its ready missiles and would require time to reload. But what the battery commander did not know was that reloading would take 6 minutes, and the remaining strike package was 40 seconds from the next defensive layer. The arithmetic of time had already tipped. The medium-range layer inside the city perimeter was a Buk-M3 battery, the Viking variant, Russia's most modern medium-range missile system. The 9S-36 passive electronically scanned radar gives the Buk-M3 a track-while-scan capability of up to 36 targets simultaneously. Its 9M317M missile is effective against targets flying as low as 15 meters. The system is fast reaction time from track acquisition to launch is under 4 seconds. In theory, at 15 meters detection altitude, the Buk-M3 should have engaged the FP2 quadrotors the moment they rose to obstacle clearance altitude, crossing the first ring of urban infrastructure. In practice, the swarm crossed the outer ring spread across a 2.4-kilometer front 6 aircraft at different altitudes, different headings, different speeds, routing through gaps between buildings and under power line corridors. The Buk-M3's fire control computer locked 4 of them inside the first scan cycle. Within 2 seconds, 2 more tracks had appeared. Then a third group, lower, approaching from the west. Then one climbing, then one descending. The fire control computer was not defeated by one powerful target. It was dragged into too many small decisions at once. Each new track forced a reprioritization of the engagement queue. Every 2 seconds, the queue changed. The system could not commit to a full salvo because each salvo it prepared became obsolete before the missiles were away. It fired on 3 of the FP2 quadrotors. It hit 2. The remaining 4 FP2 strike drones broke through and continued south toward the plant. Behind them, the 2 destroyed quadrotors had cost the Buk-M3 9M37CM missiles approximately $2.7 million in interceptors against aircraft that cost less than $60,000 combined. The Pol-21 electronic warfare network activated at 0336 hours. The Pol-21 is not a jamming system in the conventional sense. It is a GPS signal spoofing infrastructure, a network of ground-based transmitters that broadcast false satellite navigation signals at higher power than the actual GPS constellation overhead. A drone's receiver hears 2 sets of signals. The real satellites, distant and faint, and the Pol-21 transmitters, close and loud. The false signals win. The drone believes it is somewhere it is not. It turns away from its target following coordinates that do not exist, flying itself into the ground or simply wandering until its battery dies over empty water. The Saint Petersburg Pol-21 network is one of the densest in Russia, a product of the city's status as a major industrial and military production hub. The moment the outer ring radars detected an approach, the network activated automatically. By the time the 4 surviving FP2 drones crossed into the urban core, the false GPS coordinates being pushed to their navigation systems had them positioned 3 kilometers northwest of their actual location over the Gulf of Finland, approaching nothing. For 41 seconds, the drones flew on their GPS navigation. They turned. They descended. They were being walked away from the target by signals they could not distinguish from reality. Then, the flight computers flagged an anomaly. Every FP2 in this package had been modified with an inertial measurement unit crosscheck, a system that compares the navigation solution coming from the GPS receiver against the dead reckoning position calculated by the aircraft's own accelerometers and gyroscopes. The EMU does not need satellites. It knows, to a high degree of precision, where it has been and how fast it has moved. When the GPS solution diverged from the EMU solution by more than 200 meters, the flight computer did not crash or freeze. It flagged the GPS as compromised and locked it out. The drone switched to backup navigation. The Hotel Recon UAV had spent 40 minutes preloading a terrain reference map into the strike package's shared navigation library, a high-resolution thermal and optical model of the 6-kilometer approach corridor from the outer ring to the plant, built from 6 nights of observation. Every road, every railway line, every power line tower, every large rooftop in the corridor had been cataloged. The strike drones began cross-referencing their optical sensors against that map. Tree lines, road intersections, the railway spur that curved northeast toward the port, the distinctive L-shaped roofline of the Eastern Industrial Bloc. They were not navigating by satellite, they were navigating by memory. The Pol-21 network kept broadcasting. The drones kept flying toward the right building. And the irony lands precisely here. The densest GPS spoofing coverage in the corridor pointed directly at the approach path to the Obukhov plant, which is to say, Russia's strongest jamming zone was oriented exactly along the axis of attack it was trying to prevent. The Pol-21 transmitters, positioned to protect the plant, functioned as navigational waypoints for the drones that had already discarded their GPS receivers. At 0338 hours and 54 seconds local time, the final close-range defensive layer activated, a Pantsir S-1 battery positioned 1.1 kilometers northeast of the Obukhov plant on the grounds of a secondary industrial facility. The Pantsir S-1 is Russia's answer to exactly this problem: low, fast, Small targets at close range. Its 1RS-2-1E multimode radar can track targets flying at 3 meters per second up to 20 kilometers. Its 57 E-6 guided missiles can engage targets as slow as 10 meters per second at ranges from 1.2 to 20 kilometers. But the Pantsir 1 is also a point defense system, not an area system. It can engage between 2 and 4 targets simultaneously, not 12. And its magazine is finite. 12 57 E-6 missiles per launcher, 2 guns with 700 rounds each. 4 FP2 quadrotors were inbound. The Pantsir began tracking at 03:39 hours. Here is where the operating geometry became decisive. The 4 surviving FP2 drones were not approaching from one direction. 2 were coming from the northwest, routing around the railway embankment. 1 was approaching from the east, low against the factory rooflines. The 4th was coming from almost due south, directly toward the Pantsir position itself. Not toward the plant. Not because it had malfunctioned. Because it had been programmed to. The 4th drone was carrying a shaped charge warhead. If it detonated close enough to the Pantsir radar array, it would not destroy the launcher, but it would blind it. The Pantsir's radar and its launcher are co-located on the same vehicle. Damage the radar, and the missiles become deaf. The Pantsir battery commander had to make a choice: engage the aircraft approaching his position, or engage the aircraft approaching the plant. He could not do both simultaneously without splitting the engagement queue and reducing his tracking fidelity on both. He engaged the aircraft approaching his position. He launched 2 57 E-6 missiles, 8.8 million rubles each. The first missed. The drone changed altitude by 3 meters during the terminal phase, a pre-programmed jink that the missile seeker could not correct for inside its minimum maneuvering distance. The second missile connected. The third FP2, approaching from the east, was engaged with the 30 memory guns. It was hit. It crashed onto the factory rooftop of the eastern block, detonating its warhead against the roof structure rather than inside Building 7. Substantial damage, not decisive. That left 2. At 0339 hours and 41 seconds, the first of the 2 surviving strike FP2 drones reached the secondary utility annex, a lower building abutting the main assembly hall, used for component storage and staff facilities. Its shaped charge warhead detonated against the reinforced concrete outer wall. The wall held. The explosion was contained: clean rupture of the outer surface, partial spalling on the interior face, no structural collapse. Inside Building 7, 40 meters away, the night shift technicians felt the concussion, heard the alarm. But the building had absorbed it. The assembly lines were intact. The radar tracking arrays still under construction and their jigs were undamaged. No secondary explosion, no fuel bloom, no chain reaction. The operators on the thermal feed watched the structure hold and felt the operation begin to fail. But the last drone had not struck yet. At 0341 hours and 17 seconds, the second surviving FP2 strike, drone 1 of the 2 that had come from the northwest, crossed the roofline of the eastern factory block and adjusted its final approach vector. The Autel Recon UAV had flagged Building 7 specifically because of its thermal exhaust signature. The cooling systems for the radar calibration equipment ran at a measurably different temperature than every other structure in the complex. The thermal map had identified the northeast corner of the assembly hall as the hottest point in the building, where the calibration rigs were densest, where the nitrogen cooling lines ran closest to the exterior wall. The FP2 struck the northeast corner of Building 7 at a shallow angle, not vertical, but angled at approximately 34 degrees, designed to maximize penetration depth before detonation. The shaped charge warhead punched through the exterior cladding, through the insulated inner wall, and detonated inside the building. The focused metal jet ignited the calibration solvent reservoir, 800 liters of high-purity isopropyl alcohol used to clean radar components before final assembly. The initial fireball expanded to roughly 40 feet in under a second. The explosion breached the nitrogen cooling line. Compressed nitrogen at 200 bar vented into the fire, feeding it. The secondary detonation, the one that produced the 140-foot fireball visible from the Gulf of Finland, came 5 seconds later when the nitrogen pressure wave found the solvent storage in the adjacent room. Building 7's northeast wall came down at 0343 hours and 29 seconds, 11 seconds after the first detonation. The assembly hall for Russia's S-400 radar tracking arrays was on fire. The fire burned for 6 hours. When it was done, the production equipment inside the precision jigs, the calibration rigs, the antenna alignment systems was destroyed, not damaged. Destroyed. To understand what this means beyond the footage, you have to understand what the Obukhov plant produces and what Russia cannot do without it. Russia is fighting a war that is consuming its air defense infrastructure at an accelerating rate. Ukrainian ATACMS strikes have destroyed or damaged more than 30 S-400 and S-300 launch vehicles in the past 18 months. Each destroyed radar tracking module costs the Russian defense industry approximately 1.2 billion rubles to replace at current production rates. Inside the Obukhov plant, specifically, Russia cannot buy these components abroad. Western sanctions have severed access to the Dutch lithography machines, the American semiconductor fabrication tools, and the German precision machine tools that the plant relied on for its pre-war production volume. Since 2022, the plant had been running on pre-war stockpiles of critical components, cannibalizing civilian contracts to keep military production alive and improvising substitutes that reduce the performance of the final product. The assembly hall that burned on the night of this operation was not one production line among many. It was the primary production facility. Russia has no equivalent plant operating at comparable output. The Almazante concern, the state corporation that owns the Obukhov plant, has no redundant facility that can absorb this production loss. A subsidiary plant in Nizhny Novgorod produces components for the S-350 Vityaz, not the Triumf. The Fakal Machine Building Design Bureau in Khimki produces the missiles, not the radar systems. The radar tracking arrays for the S-400 are made here, and here alone. The 6 hours it burned were not just the destruction of a building, they were the destruction of Russia's capacity to replace what Ukraine is shooting down on the front line. The practical consequences begin immediately. Every S-400 battery currently deployed in southern Russia and occupied Crimea depends on functional radar tracking heads. When those heads are damaged by electromagnetic pulse, by debris strike, by the operational wear of continuous active radar emissions, they need to be returned to Obukhov for servicing or replaced with new units from the production line. That production line is now offline. Russia's forward-deployed batteries become more difficult to maintain, slower to repair, and eventually impossible to replace at current attrition rates. The second-order consequence is strategic geography. Russia has responded to Ukrainian drone pressure on Crimea by concentrating more S-400 and Pantsir assets in the peninsula and the adjacent Krasnodar region, pulling coverage away from other sectors of the front to protect what it considers an irreplaceable logistics corridor. That concentration made military sense, while the Obukhov plant could sustain replacement production. With the plant degraded, Russia faces a harder choice. Keep concentrating its best air defense systems in Crimea, knowing it cannot replace them when they are damaged, or redistribute them more thinly across a front line that is growing longer and more contested. There is no good answer to that question. Russia has to choose between defending Crimea and defending the air above its forward combat positions. A functional S-400 network in Crimea means a degraded network over the Zaporizhzhia front. A reinforced network over Zaporizhzhia means Crimea becomes progressively more exposed to exactly the kind of deep strike operation that just burned the plant building those systems. And here is the dimension that the immediate footage cannot communicate. Every drone that crossed into Russian airspace on the night of this operation cost between $15,000 and $60,000 US. The Decoy drones that pulled the S-400 missiles cost approximately $70,000. The S-400 interceptors that destroyed them cost $4 million. The Buk-M3 missiles expended in the engagement cost $2.7 million. The Pantsir interceptors cost another $500,000. Russia spent more than $7 million US in defensive fire on a night when Ukraine's total aircraft expenditure was under $500,000. The final strike that entered Building 7 and destroyed a radar production line worth billions of rubles in future output. That strike was delivered by an aircraft that cost $60,000 and a warhead that cost $3,000. This is not a battle, it is an equation. And the equation is not moving in Russia's direction. The Obukhov plant was not chosen because it was the easiest target. It was chosen because it was the most consequential one. Ukraine could have sent these 12 aircraft against another fuel depot, another railway bridge, another supply convoy. Those targets matter. They slow the logistics chain. They buy time at the front, but they do not change the underlying capacity of Russia to build the weapons that are killing Ukrainian soldiers. The plant does. Burn the factory, and you are not burning today's supplies. You are burning next year's replacements. You are shooting not at the ammunition in the gun, but at the factory that makes the gun. That is what happened at 0343 hours in the Nevsky district of Saint Petersburg. A country defending its own territory reached across 1,000 kilometers of airspace, navigated through layers of the most expensive air defense network in the world, and delivered a precision strike against the facility responsible for building those very defense layers. And it did it with aircraft that cost less than a used car. Russia will announce that the fire was minor, that production continues, that the plant is operational. Watch how long it takes to begin delivering new S-400 radar tracking heads to units that have already reported battle damage. The silence in that supply chain will tell you what the official statements will not. What do you think Ukraine should target next, the production chain or the deployment chain? Should the focus be on manufacturing plants like Obukhov or on the forward batteries protecting Russian supply lines in Crimea? Let me know what you think in the comments below. If this analysis is useful to you, hit like, subscribe to the channel, and turn on notifications so you don't miss the next breakdown. Every video we put out goes deeper into how this war is actually being fought, not the headlines, but the hardware, the tactics, and the decisions that the coverage is missing. Leave your thoughts in the comments. Goodbye.